Bismillahirrahmanirrahim. Assalamu alaikum students. So last time we were discussing applications of Newton's laws of motion. So today I will continue with that. Applications of Newton's laws of motion. So we continue with that. So I write here continue. Last time we discussed under this heading one sample problem. Today I will discuss another sample problem. We'll solve it together. So I call it sample problem 2. So let me state the problem. So it says, consider two unequal masses, two unequal masses connected by a string that passes over an ideal pulley. By ideal we mean whose mass is negligible and whose axle rotates with negligible friction. As shown in figure 1. Now it's written in the problem that this arrangement is also known as an Atwood's machine. Let M2 be greater than M1. Find the tension in the string, and the acceleration of the masses. So I draw the figure. Figure is like this. Let me use another color here. So this is my M1. This is my M2, and this is figure 1, right? So let me repeat the problem. So problem says consider two unequal masses. So we have two unequal masses, M1 and M2. They are unequal, so they are not equal. Connected by a string that passes over an ideal pulley. So these two unequal masses are connected by this string, right? They are connected by this string, and string passes over an ideal pulley. So this pulley, by ideal pulley, what we mean, I have already discussed it in last sample problem. By ideal pulley, we mean that the pulley whose mass is negligible and whose axle rotates with negligible friction, as shown in figure 1. This arrangement has a name. It's known as Atwood's machine, after George Atwood, who was an English mathematician who developed this device in 1784 for demonstrating the laws of accelerated motion and measuring acceleration due to gravity g. So then it is given that let m2 be greater than m1. So we are given that m2 is heavier, m1 is lighter. And question is, we have to find the tension in the string, one unknown, and acceleration of the masses, right? Now let us move to the solution. What we do first, we draw free body diagrams. So what are the forces acting on M1? Two forces. One is this string is holding it, so there is tension in the string, and in downward direction, Earth is pulling this M1, so it is acted upon by weight in downward direction and tension in upward direction. We call that T1, and its weight is M1G. For M2, M2 is heavier one. What is first the behavior of the system? Since M2 is heavier, it will go down with certain acceleration, and M1 will move up with certain acceleration. So M2 is also acted upon by two forces. In downward direction, it is acted upon by weight, M2G, and in upward direction it experiences tension. We name that T2, right? Then we take vertical direction as y direction. Which direction we take positive? We take the direction of acceleration of the masses, that is direction of motion, as the positive direction, right? So for M1, which is lighter, upward direction is positive. For M2, it is moving downward, downward direction is positive. So I will write free body diagram for M1. So situation is like this. Let this upward direction, because M1 is going up, I take it positive. It's understood downward is negative. So this is my M1 mass, right? There are two forces acting on it. In downward direction, one vector, there's its weight, M1G. In upward direction, another force, I name that T1, right? T1 is longer vector in the diagram because tension on it is greater than weight. That's why it is going upward, right? So apply Newton's second law. It says Fy, I write it this way, Fy is equal to M1 Ay. Fy is what? Algebraic sum of all the forces acting on this M1 along y direction. So that is T1 minus M1G is equal to M1 A1, right? Where A1 is acceleration of this mass in upward direction, which here is Ay, right? Similarly, let me make first a partition here. Free body diagram. See, free body diagram for M2. M2 is heavier. So diagram is like this. It is going downward. So I take downward direction as positive. This is my M2. Now it is experiencing weight in downward direction. M2G, and tension in upward direction, which we call T2. Use another color. Now here tension is smaller, that's why it is moving in downward direction. So it's T2, right? So applying Newton's second law to M2, I write directly what I get. M2G minus T2 is equal to M2 A2. So this is my A, this is my B. M2G minus T2 is equal to M2A2. Here I have M1G minus T1. Here I have T1 minus M1G is M1A1. Now let us move to the ideal condition. We are saying that This string is massless and pulley is frictionless and massless. Because of that, what happens? The motion of M2 is matched by the motion of M1. That is, the acceleration of M1 and acceleration of M2 are same. One thing. Second thing, the tension on M1 and tension on M2 is same. So I write here under ideal conditions T1 is equal to T2 and let that be T, and A1 is equal to A2 and let that be A. Therefore, equations A and B become, using the ideal condition, is this. So I write here T minus M1G, T minus M1G is equal to M1A. T minus M1G is equal to M1A. This is my first. M2G minus T and M2G minus T is equal to M2A. M2G minus T is equal to M2A. Let this be my 1, this be my second. Now I have to solve for A and T, right? So what we do, we solve them, or we add them, adding first and second, we get. Add the equations. My left hand side is add T minus M1G plus M2G minus T2 is equal to M2A plus M1A, right? Let me use this color. T minus M1G plus M2G minus T2 is equal to M2A plus M1A. So this T minus T2, sorry, it is not T2, it is just T, because T1, T2 is equal to T. So I need eraser. Now I need pen back. Where is my pen? Let me get my pen back. So I have pen. So this T, because we replace T1, T2 by T. So here it is T, it is T. T minus T is 0. They will cancel. Then what I get, here I take G common. I will get M2 minus M1, right? Now on right hand side I get, and I take A common, M1 plus M2. Solve for A, I get M2 minus M1 by M1 plus M2 times G. So this is my acceleration. Let it be 3. M2 minus M1 G by M1 plus M2, right? Now Using 3, you can use 3 in 2 or first. That's up to you to solve for t. Using 3, let me use this color. Using equation 3 in 2, we use 3 in 2. So I get M2G minus T is M2A, where A is this whole thing, M2 minus M1 over M1 plus M2 times G, right? That's my M2G minus T is equal to M2 times A is M2 minus M1 by M1 plus M2 times G. So we move forward, we have to solve for T. We take this to this side, it becomes positive. This to left side, it becomes negative. What we get then? We get T is equal and we take it to the right, M2G minus this I take to the right, it becomes positive. Here remains M2G, then minus M2 times A, that is M2 times A. What is that? M2 minus M1 by M1 plus M2 into G, right? Let me check. M2 times M2 minus M1 by M1 plus M2 into G, right? Let us solve. Oh, let me, what is the LCM here? M1 plus M2. And this will multiply here. M2G times M1 plus M2, right? Then what I have here, I have minus M2 square G first term, M2 into M2 is M2 square. Second term minus into minus is plus M1 M2 G, M1 M2 G, right? Then let me solve it further. Here I have M1 plus M2. In the numerator, what I have, I multiply these terms, M1 M2G plus M2 square G. And I have minus M2 square G plus M1 M2 G. Then what I get, plus M2 square G minus M2 square G will go and these two will add, which is twice M1 M2G by M1 plus M2. This is the expression for tension. So my tension in the string is twice M1 M2G over M1 M2. Let me name this 4. So we have solved our problem. This is our tension in the string in case of Atwood's machine. This is the acceleration of the masses, but we're assuming situation ideal, string inextensible, massless, fully frictionless, and massless, right? And our M2 is less than, M2 is greater than M1. M2 is greater than M1. If you take M1 greater than M2, then that is also Atwood's machine, but equations will be different. If M1 is greater, it will move down, M2 will move up. Here in this acceleration equation, then in the numerator you will have M1 minus M2, right? Tension will remain unchanged. We move to our next sample problem. I name that sample problem 3. We'll solve it together. You will enjoy. So my problem goes like this. It says an 8 Newton picture is supported by 2 wires of tension T1 and T2 as shown in figure. We name it figure A. Find the tension in the wires. My figure is like this. This is some picture. Oh, there is something on this picture, right? It is supported by 2 strings like this, right? Now, tension in this particular string is named T2. Tension in this particular string is named T1. This angle is 60 degree and this angle is 30 degree. This angle is 30 degree. It has certain mass, this picture. It is acted upon by Earth in downward direction. So it is weight, W is equal to mg. This is my figure A, right? T1, T2. Question goes like this. An 8 Newton fixture is supported by 2 wires of tension T1 and T2 as shown in figure A. Find the tension in the wire. So it is supported. Picture is static. It's not moving. It is in equilibrium. Therefore, its acceleration is 0. So let us draw the free body diagram. So this is my problem. I move to the solution. It means this color. Solution. Free body diagram of picture. So situation is like this. So let this be my x. To the right I take positive x. Upward I take positive y. Downward it is negative y. So this is my picture. It has mass m. In downward direction it has weight w, right, which is mg and which is ultimately given equal to 8 Newton. Then it is acted upon by two tensions. Now understand this my picture here. If this is 60 degree, this is also 60 degree, this one. This angle is equal to this angle. Here, alternate angles. Likewise, this angle and this angle are equal. That means it is acted upon by T1 this way, and this angle is 30 degree. Understand? And it is acted upon by T2 like this. And this angle is 60. This is my free body diagram. Now weight is fully along y-axis, but T1 is partly along x, partly along y, right? The portion of T1, the part of T1 which is along x direction, we call T1x. What is T1x? Right here. T1x is T1 cos 30 degree. This is making 30 degree with this. X is, so its projection on x direction is T1, this length, T1 cos 30 degree. What is T1y? Its component along y is T1 sin 30 degree. The simple resolution of vectors. What about T2? T2x is, let me use another color. T2x is T2 cos 60 degree, right? It's making 60 degree angle with x-axis, and T2y is T2 sin 60 degree. right? T2 sine 60. Now let us apply Newton's laws. So first I write fx is m ax. Fx is algebraic sum of all the forces along x direction. But since picture is not moving along x, ax is 0, but ax is 0. So what are, therefore it is 0. What are the forces acting on the picture in x direction? T1x and T2x, but T1x is to be taken as positive, T2x as negative. So it is T1x, therefore T1x minus T2x is equal to 0. What is T1x? T1x is this, T1 cos 30. So I have T1 cos 30 degree minus what is T2x, T2 cos 60, T2 cos 60, T2 cos 60 degree equals 0. This is my equation 1. T1 cos 30 minus T2 cos 60 is 0. Then applying Newton's second law along y direction. Fy is Ay. Algebraic sum of all the forces acting in y direction is mass times acceleration along y. But Ay is 0 again because picture is not going along y, it's static. Therefore, what are forces along y? It should be equal to 0. What are forces along y? One is T1y, T2y, and weight. But T1y and T2y are acting along positive y direction. Weight is acting along negative y direction, and which is 8 Newton. So it's T1y plus T2y. T1y plus T2y minus 8 Newton is 0. 8 stands for weight, which is given as 8 Newton, right? And 8 Newton picture. T1y plus T2y. What's T1y? T1 sine 30. T1 sine 30 T1 sine 30 degree plus was T2y, T2 sine 60, T2 sine 60 minus 8 is 0. This is my equation second, right? T1 sine 30 plus T2 sine 60 minus weight, which is 8 Newton, is equal to 0. Now I have to solve for T1 and T2. We have these two equations. I will write directly, you will check. We use blue color. So using what is cos 30 degree is root 3 by 2, and that is also equal to sine 60. Now sine 60 and cos 30 are both equal to root 3 by 2, and Sine 30 is half. Sine 30 is half, is also equal to cos 60 degree. Sine 30 and cos 60 both are half. So we use for sine 30 half, cos 60 half, for cos 30 root 3 by 2, for sine 60 root 3 by 2, and solving for T1 and T2, and solving for T1 and T2, we get, we check it at home, it is easy. T1 is 4 Newton and T2 turns out to be 6.93 Newton. So these are my answers. Tension in wire, this wire, T1 and T2 are solved. T1 is 4 Newton, T2 is 6.93 Newton. So this was my another sample problem. Now I will give you homework. Simple question. The homework is like this. Figure 1 shows figure 1 shows a block of mass m equal to 15 kg hung by 3 strings. Find or what are the tensions in the 3 strings. In the 3 strings. Figure is like this. So my figure is like this. So there is a block having mass m. It is hung by 3 strings like this. It means another color. Black. 1 string. Another string. This angle is 30 degree. This angle is 45 degrees. I name this string A, this string B, and this string C. This is my figure 1. I repeat the question. Figure 1 shows a block of mass m equal to 15 kg hung by 3 strings. What are the tensions in the 3 strings? These are 3 strings set ring A, B, C. This angle is 30. This is 45 degree. And it is understood that acceleration of the block is 0, right? So we have to find the tension in string A, tension in string B, and tension in string C. When you solve this problem, I will give you the answers. You check them with your answers. You should get TA, tension in string A, tension in string B, and tension in string C equal. Now in string A, 108 Newton. In string B, 132 Newton. And in string C, 147 Newton. I repeat, in string C, 147 Newton. In string B, 132 Newton. In string A, 108 Newton. So this is your homework. Do it. This is all for today. Thank you. And don't forget to subscribe my channel. That will help you. God bless you. Assalamu alaikum.